Okay, here we go. We're going to do 5.6. In the warm-up it says graph 2x plus y is equal to 8. Go ahead and put me on pause. Take a couple minutes. Go ahead and figure it out. Okay, notice that the equation they gave you is linear and that it is in standard form. A couple of different ways you can actually graph this. You could either unscramble it and put it back into slope-intercept form, get the m and the b in graph, or you could go ahead and find the x-intercept by substituting 0 in for y, which would give us x is equal to 4, so the x-intercept's at 4, 0. Go to your graph, and 1, 2, 3, 4 would be right there. Then go ahead and find your y-intercept by substituting 0 in for x, and we get y is equal to 8. So your y-intercept is 0, 8. 1, 2, 3, 4, 5, 6, 7, 8. Then take a straight edge. Once you've got 2 points on a graph, you can go ahead and connect them with a line. Make sure you put arrows on the ends of your line, and make sure you also label it with the original equation, which was 2x plus y equals 8. Don't forget to put arrows labeling, or else you're going to end up losing points. Alright, parallel and perpendicular lines, 5-6. This is actually a tricky section of Chapter 5. Not so much the parallel, but more so the perpendicular. Parallel lines are when two lines, in elementary and middle school they tell you they look like railroad tracks, but they're actually two lines that actually never ever touch. One of the things that you want to understand, which I'll highlight in here, is that if they are parallel, then they have the same slope. So when two lines are parallel, they have equal slope. So if you can find the slope of one of the lines, then you know the slope of the second line, as long as they tell you those two lines are parallel. So look at the question below. It says a line passes through 12, 15. This question right here does not belong to the picture above, and is parallel to the graph of y is equal to 2/3 x minus 1. What equation represents the line in slope-intercept form? Make sure we read these directions carefully. And we know that they're parallel. So if I were you, there's a couple things we could do. First of all, the equation they're giving us is in slope-intercept form. So I know that the slope of this line is equal to 2/3, which means that the equation that they want me to build that's going to be parallel to it is going to have the same slope, which is going to be 2/3. I also know that it has to go through the point 12, 5. You guys can do this one of two ways. Either one, you can substitute your m and your point into slope-intercept form, which is the y equals mx plus b, and find b, or another way, which you may not have thought of, and I'm going to actually do it this way, is to substitute it into point slope form, which would be my y minus my y1, which is 5, is equal to my m times x minus my x1, which is 12. Now, understand, they didn't want it in point slope form, they wanted it into slope intercept form. But if I put it into point slope form, which is easy with the two things I have, I can go ahead and unscramble this. Now, the 2/3 is a little bit of a headache. I can get rid of the 3. It's being divided by 3, so if I multiply by 3, this is considered to be one term. You have to do it to every term. So my new equation, this is the LCD, would be 3y minus 15 is equal to 2, which I can actually distribute, 2x minus 24. That gets rid of my fraction. Now it's in actually no particular order, but let's get it into the y equals mx plus b by adding 15 to both sides. That will give me 3y is equal to 2x minus 9. Divide everything out by 3. That gives me y is equal to 2x divided by 3. Notice the slopes are still the same, minus 9/3, whoops, which is equal to 3. So that's what it looks like in slope-intercept form. This up here would be what it would look like in point-slope form. Perpendicular lines is a little trickier. Look at the picture. Perpendicular lines literally means that the two lines are going to intersect at a 90-degree angle, like this. What you have to understand with perpendicular lines is that their slopes are actually, they say in here, is the products of -1. But one of the ways, maybe a little bit easier to understand, is if the two lines are perpendicular, then their slopes are opposite reciprocals of each other. Okay? So if they're perpendicular, then their slopes are opposite reciprocals. So if you look at the example, if this line has a slope of 1/2 right here, and the reciprocal, if this one is 1/2, the reciprocal of this would be to flip it, and opposite would mean to negate it. So that would be -2 would be the opposite reciprocal. So if one of the slopes is 1/2 and the other one is -2, that means we know that those two lines are going to be perpendicular. So let's go ahead and try an example. It says, are the graphs for y equals -5x plus 12 and y equals 4/5 x minus 8 parallel, perpendicular, or neither? Go ahead and explain. Well, really what it comes down to is we have to find the slope of each equation. So let's look at the second one is really easy. Y is equal to 4/5 x minus 8. We know that this is in slope-intercept form, so we know the slope of this one is 4/5. If you look at the second equation, which is 4y is equal to -5x plus 12, this is not in any particular form. We can put it into slope-intercept form by dividing everything by 4. That would give me y is equal to -5x over 4 plus 12 divided by 4 is 3. So the slope of this one is equal to -5 over 4. So you have to look at the two slopes of the two different lines. We'll call this slope 1 of line 1 and slope 2 of line 2, just to differentiate between the two. So we're looking at 4/5. You want to compare these two. If you notice, they flipped the number, they flipped the fraction, and this one's a positive and this one's a negative. So these guys are actually opposite reciprocals, which means, therefore, they are perpendicular. The symbol for perpendicular looks like that. So if you were to graph this, sometimes graphing it doesn't always look great because it's distorted compared to the window like in graphing calculators. Look at -8, plot that point, 1, 2, 3, 4, 5, 6, 7, 8, just barely made it. Slope says go up 4, 1, 2, 3, 4, to the right 5, 1, 2, 3, 4, 5. Then you're going to connect it with a line. And we're going to go ahead and graph the second one, which has a y-intercept of 3, 1, 2, 3, and it has a slope of -5 over 4, so I'd go 1, 2, 3, 4, 5, and +4, 1, 2, 3, 4. I can go ahead and connect those two. And we should recognize that these guys are perpendicular, whether it is not skewed or not to scale, but it looks pretty good to me. Okay, let's try this one. Go ahead and put me on pause and try this one on your own, and then have me start talking again. It says a line passing through 1, 8. Let's highlight or underline the important pieces of information. 1, 8. We know it's going to be perpendicular. That means that it's going to have slopes are going to be opposite reciprocals of the graph y equals 2x plus 1. What equation represents the line in, so they want the equation and they want it in slope-intercept form. Okay, the equation they gave you is y is equal to 2x plus 1. So the slope of that equation, I'll call it slope 1, is equal to 2 over 1. Now the equation they want me to write it into y equals mx plus b. I know that since these guys are perpendicular, that must mean that my slope of the equation that I'm building, I'll call it m2, is going to be opposite reciprocals to 2 over 1. So flip it. If this one's a positive, then you make this one a negative. Okay, so that's the perpendicular part. Now I have to figure out what the b is. Well, I could do what I did like in the warm-up, put it into point slope form and then unscramble it, or I could put it back into this equation, put your negative 1/2 in for m, your 1 in for x, and your 8 in for y, and solve for b. Okay, so we could do it that way. Let's go ahead and try it that way since we did it the other way before. So let's put 8 in for y. I'm plugging it into here, substituting. Negative 1/2 times x plus b. And I'm trying to solve for b right now. That's the other one I need. So let's get rid of this 2. Let's multiply everything by 2. That will get rid of our fraction and by using the LCD. Just make sure you do it to all terms. That 2 will cancel with that 2, which will get rid of my fraction part, but I'll end up with 16 is equal to negative 1x plus 2b. Okay, whoops. You know what I forgot to substitute? I forgot to substitute my 1 in for my x. This, you guys, I forgot to put that in here. So, this is not as hard as I'm making it. Let me go back. My bad. I can still work my 2. Maybe I still want to do that. I'll continue on that road. So the 2's cancel. Negative 1 times positive 1 is negative 1, plus 2 times b is 2b. There we go. Forgot to substitute. Add 1 to both sides because we're solving for b. These guys cancel. We get 17 is equal to 2b. Divide both sides by 2. And we get b is equal to 17 over 2. Yuck. That's all right. We can just substitute it in. We get negative 1/2, which is this, and our b into our equation for slope-intercept form. And I'm good. Even though I don't like the fractions, they didn't ask me to graph it, so it's okay. And that's it, guys. So remember, if the lines are parallel, their slopes are equal. If the lines are perpendicular, their slopes are opposite reciprocals.